Okay, one more two-dimensional momentum conservation collision question. Here we just have two objects of equal mass shown in the diagram. Determine the unknown final velocity. So there you go. So they come together, they collide, they bounce back apart. This is just a vector problem. It's a big long one, so we'll try and speed through it as fast as we can, but there's not much else to it. So I'm going to make sure I label all these vectors properly. I'm going to call this object A from now on, this object B from now on. I'm going to call this V1A, this V2A, this V1B, and then what I'm looking for is V2B. So let's break them all into components. 40 degrees here, 0 meters per second. So this, which I will call V1AY, is equal to 4 sine 40, which is 2.57 meters per second. This one then is 4 cos 40. That's V1AX. I'm just going to label the whole thing, and then I'll deal with what's what later. 4 cos 40, 3.06. So that's V1A, V1B. I got 3.5 kind of going up like this. This is 45 degrees. So this one is 3.5 sine 45, which works out to be sine 45, 2.47. And this one is 3.5 cos 45, which is of course the same because it's 45 degrees. V2A now is coming up like this. It's 20 degrees. And it has a magnitude of 3.0. So this one is 3 sine 20. Sine 20 is 1.03. And this one is 3 cos 20, which has a value of 3 cos 20, 2.82. I'm going to call this the y direction, this the x direction. So I'm going to deal with my x's first. Why not? So my initial momentum in the x direction is equal to my final momentum in the x direction. So m1 v1x plus m2 or m1 v. Oh, sorry. ma v1a plus m2 v2a is going to be equal to, see, I'm screwing this up. Let me try that all again. I'm going to get my eraser out here. All right, let's try that again. Initial momentum total, so object A's initial velocity plus object B's initial velocity. Going to my final situation, object A, final velocity, and object B, final velocity. Now we said in the question the objects have equal mass, which means all of these mass values are the same, so we can ignore those. So we just got to translate from these diagrams correctly. So we need this 3.06 as the initial velocity of object A, plus this 2.47 as the initial velocity of object B. Final velocity here, we have 2.82 for object A, and the velocity of object B is what we're missing. 3.06 plus 2.47 less 2.82, and I got V2B of 2.71. So that's in the x direction. Now I've taken care of him. him, and him. Crossing them out hopefully will help me not grab the wrong guy when I'm doing the y direction. Y. Again, initial momentum in my y direction is equal to final momentum in my y direction. Let's see if I can do this right. Mass A times initial velocity of A plus mass B times initial velocity of B. Oops, see, I can't. There we go. And mass A times final velocity of A plus mass B times final velocity of B. Okay, now, the only trick with this is that I need to declare a positive direction. So I'm going to treat what I've sort of drawn as up here as positive. Okay, so that means that this one, which is going down, is negative. Okay, he's still positive, he's still a positive, just that one right there. All these masses are the same, so I can cancel them all out. They, of course, don't equal 0. So this one's negative 2.57 meters per second plus 2.47 meters per second. That's him and him. And that is going to create a 1.03 meters per second up here. And so we just have the missing element V2B. 2.5. So this, the difference here is 0.1, 1.03, negative 0.1 meters per second, 1.03 meters per second, plus V2B. So moving the 1.03 over to the other side, V2B is going to be equal to 1.13 meters per second. Now that's in the y direction. This is in the x direction. X is bigger, so I'll start with 2.71 here, and then I'll go to a positive y. Is that positive? So that should be negative, right? Because this was negative, and when he came over, he would have been negative. So, oops, I'm just going to do a little eraser here. Okay. So, starting with the positive x, then a little bit of y in the negative direction. 2.71 meters per second, 1.13 meters per second. 2.71 squared plus 1.13 squared, square root 2.94 x negative y, what's the angle here, 1.13 divided by 2.71, inverse tan, 22.6 degrees. So, the final velocity of that object is 2.94 meters per second, x 22.6 degrees, negative y, or some people would have written this as x negative 22.6 degrees y. Either way, that is a two-dimensional collision. Made it a little simpler by the masses being all the same, but if they hadn't been, obviously you could have just put them into these equations and come up with exact values.